Hi, and nice to see you again. We now arrived at the last functional group, which describes the technologies for use or disposal of the sanitation end products. The use and disposal technologies are split in two modules. Now I will discuss the use of products as fertilizers and soil conditioners, and in the following lecture we will be looking at what can be done with effluent and other products. In this module I will show you how products can be used as fertilizer and or soil conditioner in agriculture, and I will explain what the difference is between the two. In order for the agricultural use to be safe, it is important that measures are in place to control the exposure and manage the health risks. I will give you a brief introduction of the so-called multi-barrier concept. When a single pit fills up, it is often abandoned and its content left to degrade. Fill and cover describes the way of disposing of the pit content by leaving it where it is. A so-called Arborloo is the simplest way of upgrading this solution and making use of the nutrients contained in a pit. After moving the toilet superstructure to a new site, the full pit is covered with a layer of earth and a tree is planted on top of it. The photo on the left shows a banana tree that grows vigorously on the nutrients of an abandoned pit in Malawi. Papaya, as the one from Zimbabwe on the right side, and guava have also proven to be successful. Compared to the Arborloo, there are more targeted and more effective ways to use the nutrients contained in human excreta. Urine, for example, is nutrient-rich and normally sterile, and can therefore be used as a liquid fertilizer when diluted. Its nitrogen to phosphorus to potassium ratio is similar to that of conventional fertilizers. Dehydrated feces, pit humus and compost typically contain lower levels of nutrients, but are rich in organic matter and or decomposed organic matter. They have good soil conditioning properties, meaning that they enhance the water and nutrient retaining properties of soil. We therefore call these products soil conditioners rather than fertilizers. As you know from the previous lectures, the properties of sludge can vary greatly. Sludge may be seen as both fertilizer or soil conditioner, depending on its form and characteristics. Before applying excreta-derived products in agriculture, we should make sure it is safe and put in place adequate health protection measures. The World Health Organization published guidelines for the safe use of wastewater, excreta and grey water, with detailed recommendations for different products and conditions. You can find those guidelines on our course webpage. The guidelines promote a multi-barrier approach for managing the health risks related to the use of excreta. In other words, WHO recommends to put in place several barriers if needed in order to reduce the health risks to an acceptable minimum. The figure shows different barriers between toilet and food consumption for the case of urine use. For example, treatment mechanisms like storage can decrease the number of pathogens in urine, and the use of protective equipment reduces the contact. Maintaining those barriers helps to control exposure and to keep the health risk low. I have taken this figure from the very useful publication called Practical Guidance on the Use of Urine in Crop Production, which can also be downloaded from the course page. In these pictures, you can see the fertilization with stored urine and its effect on plant growth. Urine that has been diluted with water can be applied to plants either manually or using trucks. A 3-to-1 mix of water and urine is an effective dilution for vegetables, although the correct amount depends on the soil and the type of vegetables. In the pictures at the bottom, you can see impressive trials with maize and spinach, with and without urine fertilization. The photos here show how the content of a dehydration vault is brought to a field to be used as a soil conditioner. As you can see, ash was used as a cover material, hence the greyish color of the material. If the end user is hesitant about using the dehydrated feces on his or her fields, a possibility could be to further store and compost the material before application, as shown on this picture here. Those two pictures here show the excavation of humus from fossa alterna pits after 1 year or more of storage. In this photo you can see human excreta after thermophilic composting. Both humus and compost can be used as soil amendments in gardening, for example when planting a new tree. In the case of sludge, we have to distinguish between the application of liquid and solid sludge. Liquid sludge can be, for example, the digestate from biogas reactors, as shown in this photo from Morocco. And solid sludge can originate from unplanted drying beds, for instance. The characteristics of the sludge and how it has been treated determine the necessary health precautions and application strategies. As we have seen from the examples presented in the last few minutes, improved soil quality and higher yields are two clear benefits from the agricultural use of excreta-derived fertilizers and soil conditioners. Besides that, the controlled application can contribute to reducing the environmental degradation through uncontrolled discharge and to closing the nutrient loop. Ideally, resource recovery should be the economic driver of the sanitation chain, but the market value of the different products is quite low. Research is currently going on in order to develop higher market value end products. WHO's multi-barrier approach helps to control exposure to pathogens and to minimize health risks associated with the use of end products of a sanitation system. WHO guidelines should be consulted for specific guidance. In the following module, I will talk about the use and disposal of treated effluent and a few more products.